as we go into the last section of Unit 2. A lot of material from Section 3 will be reviewed here and used, so a little more emphasis, and the title, The Time Value of Money. So hopefully something we all like to have. And we'll be dealing with these topics: interest, simple interest, future value and present interest. Again, we've done some of this. Compound interest, we did that as well. Effective annual yield, inflation. And let's start off with a definition of interest. Now, when you go to the bank and you want to borrow some money, and let's say $100, that over a period of time, when you pay that money back to the bank, you're going to pay more than what you took out. They're letting you use their money, and that extra money that you have to pay, the money gained by the bank in this case, over time, is the interest. Now, if you put into the bank $100, then the money that they're going to give you extra for using your money, that is the interest. So if you borrow money, the interest is what you have to pay extra. If you deposit money, that is the use of that money gives you an interest, which is some extra money. And as we look at some of the terms, again, principal you should be familiar with, the amount of money you're going to borrow or the amount of money you're going to put in for deposit. And then the rate of interest is a percentage of that money that the bank charges you or gives you for the use of your money. Now, there's different types of interest. If it's calculated like once a year, and that's basically it. This is called simple interest. But if during the year you calculate the interest more frequently, this is referred to as compound interest. And you'll see examples of these as we go on, and we actually had a formula for this. In Section 4 now, we have to be very careful of what they're asking us in terms of what formula we use. In fact, I'll be giving you a formula sheet to help you keep track of a lot of these formulas. All right, to start us off, simple interest, which is the capital letter I, is equal to the principal times the rate times the time. So this is one that you'd want to put as notes and keep in mind what simple interest is. Now, we'll do a problem, and basically these are to be set up similarly as we did in Section 3. Now, we don't know the interest, but we know the principal is $4,800 times the rate, which is R, 7%, that will convert to a decimal fraction, times the time. Now, the T here refers to years. We have 6 months, so we could put that as 6 out of 12, or we know that's the decimal fraction 0.5. You could have put that in as well. And then you put that into your calculator, and we see what we get. Again, I don't like the way they're putting that fraction, but that's okay. So your interest would be $168. Now, if they were asking you how much you had to pay back, you'd have to add this 168 to the 4,800. Again, you need to be careful of what they are asking. Now, we're introducing once again this idea of future and present value. So the present value was that. In the future, you had to add the interest to get the total amount that you would have to repay. Now, suppose you wanted a formula to indicate the total amount that you have to repay. So, this formula is slightly different than the previous one. And as we look at it, we see we have future amount now, which we had before. And this is simple interest. That's the key. But now future value, the letter A, is equal to the principal, and then in parentheses 1 plus rate times time. And here time is in years. So a modification of our interest formula, simple interest, to now give future value. So include that in your notes. And here's an example. So once you have the formula, of course, it's rather easy to set up. Future amount is equal to your principal, which is $460. And then 1 plus the rate, which is going to be 12%, that I'm going to put as a decimal fraction, times the year, but we have to show the year now as 8 over 12. And 8 over 12 could also have been written as the fraction 2/3. So we could have put 2/3 here. So what we're going to do is do this calculation and then add 1 to it, again putting it in your calculator, multiplying it by 460, and that would give you, as you'll see, the future value. Which would be $496.80. And hopefully you're putting the examples as example 3 of the PowerPoint series. Alright, example 4. If you can earn 6% interest, what lump sum must be deposited so that its value will be $3,500 after 9 months? So here you know the future value, you know A, but you don't know what your principal would be. So again, we're going to use this formula, but we want to solve for the letter P now. And let me work that one out for you as well. We see it written there, and I'll just go over the steps with you. So we have future value, which is going to be $3,500. That's going to equal P that we don't know, and then 1 plus 0.06. And then here I can reduce this to 4/3, 3/4 I should say, times 3/4. And I'm going to put this as 0.75, which is another way of writing that. But again, that's a year, fraction of a year. So what I did is I put this part, I multiplied these two decimal fractions, and that was 0.045, added 1 to it, and I got this. Now, to solve the equation, I'm going to divide both sides by 1.045. And then I get P on this side, since this cancels out. And when I do this division, I get approximately, because I had to round off a little bit, $3,349.28. So there was the original principle that I had to put into this equation here, so that I would end up with $3,500. So you see, this is a little bit less, but you're getting interest. This is the interest that you're getting on that principal. Okay, again, hopefully you've copied these steps down. For example, 4. And let's go on. Now, this is one we are already familiar with. That is compound interest. And the compounding period we've done in section 3. So there's a little repetition. Now, the only thing about this is that they've changed the letters a little bit. So you can use these new letters, or you can use the letters we had before. And if you recall, the letters we had before was an N down here, and then we had N times T up here. Now, what they're saying is that this N is the product of N times T. So, again, you could use, I think this one, why they changed that. There's a little change in letters. I'm not sure, but we could stick with the one we already know, or, as I say, you may note this little modification. This N here is referring to the month, the number of compounded times during the year, times the years. All right, a little change. So we're used to figuring these out, and you'll want to include this one in your notes as example 5. You can use this formula or the other. You're going to fill it in. And keep in mind, if it's for 8 years and it's compounded quarterly, that would be 4 times 8 is where you get the 32. And then there's the calculation to give you future amount. But again, we've done examples like this in our previous lesson. All right, for example 6 now, our PowerPoint slide, what would be the present value? Now, we're not looking for future value, we're looking for P. So let's just go over that, how you would solve it. The formula A equals P times 1 plus R, and if we use the older formula, N times NT. Now, if we want to solve for P, at this stage, we could just divide both sides by this, 1 plus R over N, NT, and then A would be 1 plus R over N, NT. So on this side, all of this would cancel out. So the formula we'd use then is a modification where we're looking for our principal, and then let's fill it in now. Our future amount is going to be $18,000, but we're going to divide that by, and then in parentheses, 1 plus our rate, which is 5%. It's going to be compounded monthly now, so that's going to be 12. And then this would be 12 times the 20 years, which would be 240 here. So let's change that now that you see where it came from. And then plug that into your calculator and get your results. And it would be $6,635.60. Again, this was the original amount that you put in, but at compounded every month for 20 years, the 6,000 or 7,000 comes up to be 18,000. Wow. This is the power of investment, and 5% is a pretty good one in today's market. Let's go on. Now, another term we want you to include in your notes is this: effective annual yield, often written EAY. Now, when you put money into a bank account, and let's say it's at 5%, but if it's going to be compounded monthly in terms of simple interest, in a sense, you're getting more than 5%. It might be 5 1/10%, or 5.1%, or 5.12%, depending upon how often it's going to be compounded. And this is called the effective annual yield, and that's what they describe here. So, what is the effective annual yield? And that's what we're going to take a look at. This is the formula for effective annual yield, and you want to write this up in your notes. Now, M is the period of compounding, so we'll have to use the M here, and this is that same value. Now, this is the basic formula. There's no T in here. We're just using M, because that is what's going to determine the little bit of interest that you're going to get more, the interest rate more, because it's compounded that often during the 1 year. So as we go to the next one, we're taking a look and we're seeing what is the effective annual yield if the nominal rate is 4.2%, but it's compounded monthly. So here your M is going to be 12. This is 12, and this is going to be 0.042. So again, you're going to write this down as you look at the solution. So 0.042 divided by 12, you're going to add 1 to this, and once you get all of this, you're going to raise it to the 12th power. Then you're going to subtract a 1 from it. So a effective annual yield starting at 4.2%, you're actually getting 4.28%. Again, because you're compounding that more frequently. And again, do this calculation to be sure you're computing it correctly. So, generally speaking, for effective annual yield, you're always going to have a little bit higher percentage than the rate that's listed. All right, moving on, we're taking a look at what is called inflation. Back when I was your age, a hot dog was like maybe 40 cents, and a drink was 10 cents. Gas was 29 cents a gallon. And of course, today you know that hot dogs don't cost 40 cents anymore. And gasoline doesn't cost 30 cents a gallon. So over time, the value of goods, their price increases. And therefore, this is described as inflation. And they're describing it as, in the sense, the money loses its value. So the loss of value of money, or the increased value of goods, another way of stating it, this is described as inflation. Now, if the price of goods becomes less, that is deflation. That happens every once in a while, particularly with a new item. I could recall a television set, a flat screen that I bought, 28 inches, 15, 16 years ago, was $1,200. Now that might be $250, $275. So, in a sense, that would be deflation of the cost of that item. But in general, goods tend to cost more, and this is inflation. Now, what the Bureau of Labor Statistics publishes, what they call a consumer price index, which is CPI. And then in our textbook, and I think I have this duplicated somewhere, you'll actually see this listing and the statistics portrayed year by year as to what they figure was the increase in items, that is, the inflation. Now, we figure future value for continuous compounding is a formula we are already familiar with from section 3. So, future amount times the principal, E, Euler's E, and then the exponent, rate times time. Time here is years. So let's take a look at this. Now suppose, and this is example 8, that a cup of your favorite coffee is $2.25. If the inflation rate persists at 2% over time, find the approximate cost of the coffee in 25 years. So let's set this up. We'll do it together. So future amount equals, the principal in this case is just $2.25. We're going to times that by E. But before we do that, we have to raise E to the exponent 0.02 times the t here, 25 years. Now, theoretically, if you put all of this 2.25 e caret, and then this in parentheses, it'll give you the answer in one swoop. Or you could put e, and then put this in parentheses, and then times it by this. It should work either way because the calculators know that it has to do the exponent first. All right, let's see it worked out here. And there it is. So, in 25 years, that coffee cup that you paid $2.25 for, it now costs $3.71. That is inflation. The amount that your money will lose value, but in a sense, the product you're buying increases in value. And that's why generally wages go up over the years. So we see this particularly in buying homes. When you buy a home at a certain price and you take a mortgage, then over the years that house would increase in value, theoretically, but you're paying interest on what it was when you bought it some years past. Now, there is a problem with this, that as inflation increases, and then people realize they don't have the money to buy these, and you get what they call a bubble of inflation that burst. And we saw this in 2008, where, houses that were $400,000 and $500,000 were now worth only $250,000. So people who were paying mortgages on $400,000, we say they were underwater. That is, your mortgage is underwater. That means you're spending more than the value of the house. So, again, there's a lot of material in this section that is sort of useful for future financing as you get into adulthood and into these areas of savings and mortgages and value of money, which is what this lesson is all about. All right, let's go on. Now, they also have an inflation proportion, where we have the price in year A in proportion to the price in year B is equal to the consumer price index of year A to consumer price index of year B. Now, this gets a little challenging, and we'll just follow along with what they're showing us here. And again, this is example 9. If your mother paid $3,000 in tuition in 1980 at the same college that you will be attending and paying $9,300 in the year 2005, compare the school's tuition increase to inflation over that same period of time. So you're going to set up a proportion. So the price in 2005 compared to the price in 1980, the CPI in 2005, CPI in the year 1980. And they work that out. And then here we don't have that information, but we'd have to get it from some sort of chart. Just copy it down. Again, we don't know what it should be. Now, when we figure it out, and we do the cross multiplication, we get $7,110.44. We're just rounding that off. Now, when you compare what it should have been in that time to what it actually is, you'll see that the price has increased by 30% beyond what normal inflation would result in. And you might say, why is that? Why is it more expensive? Well, I think part of the reason, and I'm not a super expert at this, is that schools, when you think of the equipment, the smart boards, the projectors, the computers that they're putting in place for students, this is quite expensive. So that the universities today find that there's more cost on their part and therefore higher tuition rates. Well, that's my 2 cents. Okay, example 10 now is a method of estimating how many years to double the value of something, in which we use what is called the rule of 70. So here's the basic formula that you want to write down. The years to double is approximately 70 divided by the annual inflation rate. So if something was $1, how many years before it's $2, the value of that product? And we use this shorthand technique of dividing 70 by the annual inflation rate. Let's see the example. So we're saying the inflation rate is 2.1%, which is not too bad. So we take 70. Now note here, we're not converting the percentage rate to a decimal form. We're using the actual percent, dividing 70 by the percent. And it's about 33, or as they're listing here, rounding it up, 34 years. So sort of an easy example here, but you need to know the formula. 70 divided by percent rate. Okay, that completed that lesson. Again, there was some review, some new items, but again, dealing with money. So a lot of these, as we do these examples, we're going to see familiar items here. So simple interest is straightforward. Interest equals principal times the rate times the time. You just want to note these, copy them as examples in your booklet. This is the formula. This is the substitution. This is the interest. That is money you would have to pay in addition to the amount that you borrowed. Or if you put it in for savings, money you would earn extra above the initial amount you put in. All right, number 2. This is future value for simple interest. And there is the formula. And we want to be able to put it in. So let's do this one. And we'll just set it up. So future value. Now the principal will be $210 times 1 in parentheses plus your rate, which is 6%, times the year, and it's going to be 8 months, so that would be 8 over 12, or 2/3, and then put that in your calculator. Again, I would do this multiplication first, add 1 to it, and then multiply it by this, and that will give you the answer. And here the future value of borrowing 210 is $218.40. Now the question is, what was the interest here? Well, the interest is, you have to subtract the 210, would be $8.40. So you need to be careful. What are they asking you? Here they're asking for future amount. But if they're asking for interest, it would be the $8.40. All right, there's the formula for where we have A, but then we solve for the letter P, we get this. And we'll use the book because they give a nice explanation. So our A is 210, and it will be all divided by this. Again, when you put this in your calculator, you'd have to put this in parentheses to be sure you end up with the proper amount. And again, trying these on your calculator is a very useful exercise. All right, now here they're going to compare simple interest to compound interest. And we're just going to take a look at this one because this is a little tedious. You will have one like this for your homework, and you'll just have to grind it out. There's your basic simple interest formula. And then taking it from 1 year, then the next year you have a little bit more, so that for 5-year growth, you end up with, if it's done through compound, you end up with $16.64 more because of the compounding factor. And it's illustrated in this chart here. Here's simple interest, and there it takes you through compounding, where you have a principal that changes each year as you add the interest earned. Notice it becomes slightly higher. And then compounded interest we've used before. So there's this principal at 3% compounded quarterly. This would be 4. Here, this at this interest compounded monthly. This is monthly. Now, this one's sort of interesting. So let me set this one up for you. So it would be your principal. Let's use, well, the formula is there. So A equals 3419 times 1 plus 0.005 0.041. Now it's going to be compounded monthly. This is 12. But here's the tricky part. It's going to be 12 times. Now you have 30 months. So how do we convert 30 months to years? So 30 months, as we see here, is 30 over 12. This is now in years. We can take a 6 out of each one of these, which is 5 halves. And 5 halves in decimal form is 2.5 years. So we're going to multiply that by 2.5 here. So that was the little tricky part when they gave you the 30 months. So let's go on and take a look and see what they've done here. So what they have done here, as we look, they're getting n, which is 30. And remember, it is n times t. And we're saying our t is, this is 30 months, 5 halves. And then our period of compounding was 12 months. But notice the 2 now goes into there once. 2 goes into there 6 times. And we ended up with 30 anyway. So that's sort of interesting. Our exponent is 30, multiplying through. And we will lower this. You can see the actual end part here. I can here. Anyway. There it is. So the earned interest is $368.38. The future value was this. Once we subtracted the principal, that would give us our present value. Okay, let's go on. Here, Lisa will need this much in 5 years to help pay for her college education. What lump sum deposited today at 4% compounded quarterly will produce the necessary amount? So here we have future amount. We want to find the original principal that you would invest. And there was the formula we went over. Substituting, and our total exponent would be 20. So you would have to deposit $22,127.70 today. Now again, if I worked all of these out in great detail, it would make this a little bit long. You're going to pause, and again, be sure you are looking at the formula we would use. And you could try these on your calculator. And be sure to put the answer in your booklets. In a savings account paying 3% interest, compounded daily, when will the amount in the account be twice the original principal? All right, let's take a look at this. Now, this one is one we also used in section 3, where we converted it to logs. Let's take a look at it. We'll follow it step by step. So again, we're looking at P is our original principal. We don't know what that is, but we want to double it. Okay, so what they're going to do is use algebra to divide out the P's. So these cancel out. Now, they're using another higher math level here, where they're going to use logarithms, and there is a key on your calculator for this, but they're using a technique that we haven't done before. They're going to convert this to logs here, as you see in the next step. And one of the rules when they convert this to logs, that the exponent goes from being an exponent out to in front of the log. So now n is what we're looking for, our exponent, because we're looking at the amount of time. Now keep in mind we are using days. So what we're going to do is divide this side here by this, and divide that side by this, which they're showing in this stage. And if you put this in your calculator, log of 2, and then divided by, and then hit log, and then all this in parentheses, this, you end up with this. Now, we're not going to have any on our homework, I don't believe, that is this challenging, and using this kind of advanced mathematical technique. But this gives you the number of days down here, which turns out to be 23 years, 39 days, ignoring leap year. So you're just going to write this answer in your booklet here and not necessarily need to know how to do this. This is for a class beyond what we're doing in our just survey course. All right, let's go on and see what's next. And here they want you to compare retirement plans. Both plans earn 8% annual interest, and then the specifics are given here and there, and we'll just take a look at this here. And notice they have it laid out nicely. And again, you wouldn't be asked to do anything like this. But notice that Plan A at age 65 ends up with $428,000, while the other only $344,000. Still a good amount. But the key is, in all of this, is that you are getting what kind of interest here? 8%. Again, you don't get 8% these days here. The only way you get close to 8% is if you are lucky in the stock market. And again, that can be a little bit of a gamble. So I just thought this would be interesting, and you don't need any details of this one. Just note that in your booklet. Now, one like this you would have, finding effective annual yield. Now, the key is it's going to be compounded quarterly. So it's going to be a little higher than this. So as we put that in the formula, we see it grows to this. So when you subtract 1 from this, you end up with 2.52%, because it's quarterly. Now, if it were monthly, it'd be a little higher, because this number here would be 12, and this would be 12. This is one you're likely to get, so be sure you know how to do this for your homework. And we did do one like this in our PowerPoint slides. So effective annual yield, they're wondering which would be the better company. And let's just look at what they've done here. They've figured out each one. And since this is annual yield, this is what you get. So as we look at them, in the friendly credit union, your effective annual yield is 2.1%. Here, Premier is 2.09, and Neighborhood is 2.07. So a lot of calculation, which is your best bet. Well, you just look at, we did something like this when we're talking about ounces and which is your best buy. So it would be friendly. And even though this is 8% or 8/10 here, 8/100, 9/100, notice because of the effective annual yield, this is your best buy. And I believe this is our last one here. We're looking at future value A. You earn this much at 2% and 13%. Let's just follow this. So for A, it would be over 50,000. And for B, for levels of inflation, it would be 458,000. Wow. So again, I don't know if you're watching world events in Venezuela because of the economic situation and the government and politics. They say inflation is not 8%, but 2,000%. So it's outrageous is what's going on down there. But again, we're just taking a look at that. Wow. So if inflation were 13%, this is where the Fed, I don't know if you've heard of that before, would come in and, try to tinker with the levels of money and interest rates and things like that. Again, we're not going into that in great detail. And this is that chart I was telling you about that I would show you earlier, comparing tuition increase. So we did that, and then there's the chart to figure it out. And let's take a look at this, how you set it up. I think you have one like this for homework. So again, they'll have to give you the information in order to do it. And when they finally get to the end, what it would have been and what they pay, this is normal inflation, this is what they actually paid. There was an increase over the inflation rate by 21% more. And I think we've mentioned possible rationale for this. Okay, this is running a little long, so we want to just complete this. Doubling time, that was the easy one. It's going to be 70 divided by this, and it would be about 31 years. And there is no time, so we'll wind this up.